So I'm going to give you around 3 injections, which will make you be very healthy when you are answering MCQ questions. And if you are new to ProfLearn YouTube channel, in this particular video, consider subscribing so that anytime we're going to upload another tutorial, you'll be notified. For you to access this particular PDF, you can be able to see here. You can be able to get it from our Patreon page. Just join there so that you can be able to be in a position of downloading this paper. Moving to this area, moving to this particular tutorial, we have tried to bring together different questions from different exams, which will enable you to prepare well for this particular exam. So in this tutorial, we are going to focus all the way from 2025 electricity MCQ questions. We'll move all the way to 2019, and I believe if you go through that, you'll be in a position to answer different questions as far as MCQ is concerned. Now, to get started, we need to look at this paper has 40 marks, but we are focusing only on MCQ. You'll be provided with some data, and also you'll be provided with some few formulas which will enable you to approach this particular question. We are told two identical conductors X and Y are made from the same material, and the conductors have equal length but have a smaller diameter than X. So we have Y as a smaller diameter, and then which row compares the number of charge carrier passing through X and the average drift velocity. So something that we need to understand here is that when the two conductors are connected in series, they are going to have the same current. Same amount of current is going to pass through here. The current that is going to pass through is the same current. So current I will be the same. So the current that is flowing here is basically the same. So which means how do we define current? Is the rate of flow of charge. So the number of charge carriers per unit time is going to be the same because there is same current that is passing. So that's why I selected option D. But for the average drift velocity, we know that I is equals to, let's just NVQ A NVQ. So if you make V the subject for velocity, you're going to realize that drift velocity is going to be inversely proportional to the cross-section area. So what does that mean? If the area is large, the drift velocity is going to be small. If the area is small, drift velocity is going to be larger. So average drift velocity in Y is going to be greater than X because in X we have a larger diameter, and if we have a larger diameter, the cross-section area is going to be larger. So basically that's what we are going to do, and our correct answer in that case is going to be D. Yeah, so a copper wire is 6.4 centimeters long and has a resistance of 0.92 ohms. The resistivity of copper is 1.8 times 10 raised to power negative 8. So what is the diameter of the wire? So in order to answer this question, we need to understand that resistance is equal resistivity times length over cross-section area. Then this area that we have here, we can be able to say area is, if we make area the subject of the formula, we're going to have area is equals to resistivity times L over area. But how do we get area? Area is a half pi d over 2 squared, and then if we work it out, we're going to have area equals to pi squared, pi d squared over 4. So we can be able to substitute this formula. In this part we have a, and we make d subject of the formula, then we find the square root both sides, and that's going to give us d is equals to 4 resistivity times length over pi r. Then when we substitute the values, because we have 4, our resistivity is 1.8 times 10 raised to power negative 8, and we have the length as 6.4 meters. So always, whenever you're going to do this question, check whether the units are okay, and then we divide by pi or times 0.92. If you work it out, you are going to get your answer being approximately 4.0 times 10 raised to power negative 4, and that is going to be option C. So that's what we're going to work out. And the thermistor is connected. We have a thermistor which is connected with negligible internal resistance, yeah, to a cell. The cell has negligible internal resistance. So we are asked which graph shows the variation, which graph shows variation of with temperature of the power dissipated in the thermistor. But we know as temperature increases, resistance of a thermistor decreases. Yeah, so as temperature increases, resistance decreases. And if resistance decreases, there will be more current that is going to flow in this circuit. So in that way, if there is more current, we need to remember that power dissipated, power lost is equal to P equals to I squared R. So which means that we are going to have power increasing, and power will increase. The reason as to why power is going to increase is because when you reduce resistance, current increases. Yeah, sorry, when you increase temperature, resistance decreases, then current is going to increase. And since power is I squared R, it means this graph gonna look like this. So we shall have option A. I don't know whether such kind of questions could make you so much worried. I don't know whether you are a patient in this type of MCQ questions. If you are new to ProfLearn YouTube channel, consider subscribing so that when I'll be uploading another clinical video, you'll be notified to avoid a situation whereby you are placed in the intensive care unit during the exam. Yeah, so let's proceed. Let's move on to the next question. And in this next question, we are told that this 2025. I picked this from 2025. So we shall proceed that way downwards until 2019. Then by the time we are done up to 2019, I think you'll be quite well. Yeah, you'll be quite well for you to go to the exam room while healthy. A metal electrical conductor has a resistance of 5.6 kiloohms and a potential difference of 9.0 volts is applied across it. How many electrons pass a point in 1 minute? In 1 minute, how many electrons pass through a point in 1 minute? What do you think? How are we going to go by work out that question? What do you think we're going to do in order to work out that question? Just write in the comment section how we are going to work out that question. Yeah, so how do we go about that question there? Yeah, write in the comment section what do you think we're going to do there. So here we are told the duration is actually 1 minute, so which is a good thing. So something that we need to remember is that resistance, because we are given resistance here, resistance is equals to V over I. then current is V over R. So we are going to use current equals to V over R, and at the same time we know that charge is equals to IT. All right, so which means that from this particular part we can be able to say, because current is V over R and we know that charge is equals to IT, we can be able to say number of electrons times the charge of one electron is going to give us Q. So we can be able to replace Q with NQ, which means that and our current I, we can replace it with IV, V over R. Then now we have the T, we multiply it here. Then since we are looking for number of electrons that pass, we're going to divide by Q both sides, and our main now formula we shall be able to use at the end of the day in this exam is N, number of electrons, is equal to the voltage or the potential difference times the duration, which is 60 minutes, of resistance times the charge of one electron, which is basically the charge of one electron is usually provided here, which is 1.6 times 10 raised to power 1.6 times 10 raised to power negative 19. Yeah, so I'm trying element of that. This is it. This is the charge you shall be using. Yeah, so for electricity you'll use this formula here, that's constant, and also the formula that you'll be using for electricity is combined resistance. We shall be using that formula, and also for combined resistance for parallel we shall be using this one. But I'll mostly in my paper, when I will be doing for resistors which are parallel, yeah, parallel, you will be seeing me using this formula, 1 over R. I'll be using 1 over R1 plus 1 over R2 raised to power negative 1, so that I get the answer direct, because if you are using this you have to find the reciprocal at the end of the day. And then another formula you'll be using is this one also, current is equals to cross-section area times number of density charge carriers, drift velocity times the charge of an electron. So those formulas should be live in your mind. You should be able to remember them for safety and for security purposes. The next question that was asked here in 2025 Febmarch is in which circuit does not represent electric component. This actually does not represent, it's not intended to make sound, to produce sound, because this is actually, this is an electrical heater. This is an electrical heater. Yeah, so this is an electrical heater in this case. In question number 35, the diagram shows a junction in a circuit where 3 wires PQ are meet, and the currents in P and Q are 1 ampere. So which means 1 ampere is flowing here and another 3 amperes flowing there. So meaning that this current that was moving from this end to join this, the rest is 2 amperes, so that we have current going into the junction is equal to the current getting out of the junction according to Kirchhoff's first law. This is the law of conservation of charge. Yeah, so we are how much charge that passes. We know charge is equals to IT. Charge is equals to what? IT. So which means that we know the current. In this case, the current is given, we have gotten it, we have written it. Then we can be able to say now, since it's 3 seconds, so 5 seconds, we can say it's 2 times 5, which is going to be 10. Yeah, which is going to be 10 coulombs. And that is the correct answer for that. A cell of electromotive force, number 36, the cell of electromotive force, EMF, E, and the internal resistance R connected in series with switch S and external resistor R. And in this case, when we are talking of this, the switch is open. The potential difference between P and Q is V. The PD between P and Q is what? Is V. Which statement is correct when the switch now open from open to closed? If the switch is closed, there will be current that will be drawn out of because of this external resistor that we have here. So which means current will be drawn out, but there will be there will be a potential drop across the internal resistor. So if we are having the PD that drops across the internal resistance, internal resistance is going to be the current that will be drawn out times the resistance, yeah, times the resistance, the internal resistance of that cell. So in that case, we're going to say V. About V decreases because there's a PD, a potential drop across the resistor. So we're going to say V decreases because there is a potential drop across the internal resistor. So that is what we are going to say. 34. Now we have moved to a different paper. Moving to 34, we are saying that a resistor dissipates 25 watts of power when there is a potential difference of 4 volts across it. What is the resistance of the resistor? So something that you are supposed to remember is that we get power dissipated using different formulas. So we can be able to get power from I squared R or V squared over R or current times voltage. But in this case now, since we are given the potential difference and we have the power, we are working out resistance, then the best formula to use is P is equal to V squared over R. So if you substitute, you are going to get your answer equivalent to 0.64 ohms in that case. Okay, so moving to question number 32, I believe you are getting value, you are benefiting from the tutorial. We are together up to that point. And if you are getting value, consider giving writing the comment section that you are getting value, so that I can be able to know whether you are getting this better. Okay, yeah, quite sweet, huh? It's quite sweet content, quite sweet questions, very interesting, very sweet. Question 35, the diagram shows a cell with internal resistance connected in parallel with a fixed resistor, the variable and a variable resistor. So we have a voltage, a potential difference, a voltage there. Now the voltage that is being read here is basically the voltage, the terminal voltage of the cell, yeah, because these components are in parallel. So if we are having a voltage down here is actually the same voltage, this will be having the same voltage, this one will be having the same voltage, right? Then what happens to the potential difference V across the variable resistor when the current in the variable resistor, the resistance of the variable resistor is decreased? Resistance of the variable resistor is decreased. Yes, the resistance of the variable resistor is decreased. So if the resistance of this variable resistor is decreased, what will happen to the total resistance of the circuit? What will happen to the total resistance over the resistance, the total resistance of the circuit? We realize that if that's the case, when the resistance of the variable resistor decreases, the overall resistance of the circuit is going to reduce. And when all overall resistance reduces, there will be a larger current flowing in the circuit, because the less resistance result to more current flowing in the circuit. So if this resistance of the variable resistor is decreased, there will be an increase in the current, right? So in that case, current is going to increase, yeah, and since more current is being drawn and there is this particular cell has internal resistance, so there will be a larger potential drop in the internal resistance. So the terminal voltage is going to reduce. So if more current is drawn from a cell that has internal resistance, it means that there will be a larger potential drop due to internal resistance. Then it will mean that the terminal voltage of the cell is going to be lower. So that's why we are going to say current will increase, because decrease in resistance increases current, and then the voltage is going to reduce. Yeah, we shall have another clinic for particle physics, so I don't want to mix patients. Yeah, I want to have only the patients of electricity. And if you are one of them, I believe you are getting value. What's the definition of potential difference and EMF? And so potential difference and the EMF actually is charge, energy transferred per unit charge, and that is going to be, both of them, they have the same definition, but for potential difference is energy transferred from electrical to other forms, yeah, per unit charge. But for EMF is energy transferred from chemical to other form, right? Yes. The diagram shows the network consisting of 3 resistors. What is the combined resistance of the network? So something that you want to realize is that this one is parallel. So I will use the formula I told you I'd be using. I'll say 1 over 1.2 over 1 over 4.7, because these two are parallel, raised to power -1 to get the answer direct. Then since these two are in series with this, so after getting this combination, we can be able to add to this. So we are going to say 2.2 kilo ohms plus 0.96 kilo ohms, and that is going to translate to 3.16 kilo ohms. Right. Okay, so that is basically what we are going to do. That's what we are going to do at that given point. Any question up to that point? Any question? Any question up to that point? We can move to the next part of the question. The combined resistance, so it's 3.2, because this is 3.16. When we round off, it becomes 3.2 kilo ohms. This one already we have done that. We have already done that. So moving to question number 9. What is the definition? What's the definition for potential difference across the components? What's the definition of potential difference? Is energy transferred per unit charge. Energy transferred per unit charge. The diagram shows a cell of negligible internal resistance connected to a switch and 2 resistors R and 2R. So we are told the circuit also contains 2 ammeters, X and Y. The reading of X is 4.0 when the switch is open. So when the switch is open, the connection that we have is this part only. So we can be able to use it in order to know what was the voltage, the potential difference of the cell. So we know that potential difference is equals to IR. So if we use the current we are told here is 4 times the resistance R, so it's going to be 4 R. So the potential difference is 4R of this cell that was used here. Okay, now once we have done that, if this is going to be closed, it means that we are going to have two resistors which are in parallel. So we shall say 1/2 plus 1/1, because this is R, this is like 1R, and this is 2R. So we can be able to say 1/1 plus 1/2. Then we're going to get the total resistance to be what? 2/3 ohms. Resistance of 2/3 ohms in the entire circuit. So if we want to find the current that is flowing through when we have the resistance of 2/3 ohms, we are going to say voltage over resistance, and our resistance basically is this 2/3R. And if you work out, you are going to get the current that is flowing through in this circuit when the switch is closed is going to be 6 amperes. So X will be having 6 amperes. So if we want to know the reading or the current that is flowing here, we are going to use this resistor that we have here and the potential difference at this particular point. So since this connection is in parallel, it means this will be having 4R volts, this will be experiencing 4R volts, this will be experiencing 4R volts. So we are going to say current Y, current that is passing through this part, is going to be the voltage there, which is 4R, over the resistance in that section, which is 2R. So if you work it out, you are going to get 2.0 amperes, because this and this will cancel out. We shall have 2 amperes. And that's why now our answer is going to be in A 6, and in Y we are going to have that one. We have the IV characteristics of 4 components A, B, C, and D. They are shown there, and which component has the greatest resistance. And remember, resistance is given by V over I. All right, so up to that point, we've worked it. We have tried to move on. We are making steps. We are moving forward. Let's check which is the other questions that we're gonna look at. Now, we've answered question 31. Now we have question 32. And question 32, we are told a cylindrical wire has a cross-section area A and a number of density of free electrons. Number of density of free electrons is N. The wire has a current I, and free electrons have a drift velocity of V. The second wire has a cross-section area of 0.5 amperes. So, which will mean that in order for us to work out this question, we are going to use this formula. I is equals ANVQ. And then for the second wire, we are told the cross-section area is 0.5. So we are going to say 0.5A times 2N times 2V, then times Q. Then you see, if you multiply everything, you are going to get I2. The current for the second wire is going to be 2ANVQ. But ANVQ is equals to current 1 for the first wire. So which means we can be able to say current Q is basically 2 times current 1, and that answer translates to be C. That's what we are going to do in that particular part. For question number 33, electric current is formed by moving charge carriers. What is not possible charge for the charge carriers? So what you need to do here, in every quantity that you have here, you divide it by 1.6 times 10 raised to power negative 19, because charge is discrete. Yeah, so if you have 1 electron, is 1.6 times 10 raised to power negative 19. If you have 2, it will be 3 point, yeah, it will be 3.2 times 10 raised to the power negative 19 and so forth. So there's no way you can be able to have a fractional charge because charge is discrete. So you are going to take every value that you have here, divide by the charge of 1 electron, and you'll realize that this is going to give you a fractional, and it does not give you a whole number. Everything, this will give you a whole number, this will give you a whole number, this will give you a whole number, but this one will not. So charge cannot be negative 2.4. okay, which description of Kirchhoff first law is correct? How does Kirchhoff first law state? Remember, Kirchhoff first law is the state that if you are having a junction and you have 2 wires meeting there, and there's a wire going that way, so current flowing into the junction should be equal to the same current to the current going out of the junction. So if you are having 1 ampere here and you have 3 amperes here, this must be 4 amperes because there is conservation of charge as far as Kirchhoff's first law is concerned. But when we are talking about Kirchhoff's second law, that is the law of conservation of energy. The sum of EMF around any loop is equal to the sum of PDs around that loop. So, which means that if you are having a cell here, and then you have a resistor here, and you have another resistor at this given point, yeah, so, and you have another resistor here, so which means when current is going to flow around this loop, this is a continuous loop, it means the voltage drop here and the voltage drop here and the voltage drop here will be, if they are added together, they must give you the sum of the will give you the EMF. So which will mean that we are going to say that sum of all the EMF should be equal to the sum of the PDs in a single loop. So this is going to be V1 plus V2 plus V3. So Kirchhoff's second law is the conservation of energy, but Kirchhoff's first law is conservation of charge. All right, so that is basically what you are supposed to do. That given point, that's what you are likely to do in order to earn your marks. So in order for you to access the PDF of this solution that I'm doing here, you need to go and join our Patreon page so that you can be able to download the PDF and you continue learning. So let's now proceed and continue to the next question so that we can be able to finish this clinic. I know there are others who are waiting for a different diagnosis. Yeah, this, so we call this diagnosis tutorials. Yeah. Okay, so two resistors of resistance R and capital R are connected in parallel. The values of resistance R is less than that of R, which is the statement about the combined resistance is correct. So something that we need to understand. Let me just suppose use 2 here and I use 4 here. What is the combined resistance? Combined resistance for the circuit R total is going to be 1/2 plus 1/4. So once you have done that, you say -1. So that is so. Don't know why this microphone is a bit far. Okay, can you hear me now? Okay, so we're going to say now the resistance will be 1/2 plus 1/4, then raised to power -1. The final answer becomes 1.33. So the total resistance becomes 1.33. So what do you notice? What do you notice? When resistors are combined in parallel, the combined resistance should be and must be less than the smallest resistance that you have there. So which will mean that this one is going to be what? it's less than R, because we are told R is less than R. Okay, so that's exactly what you are going to do in that case. Moving to 36, it's A, because here current is going to be shared, and since all the resistors are identical, it means that here we are going to have a greater current. And we remember that power dissipated is equals to current squared R. So that is going to be A in that point. There are three resistors. There are three resistors in series as shown here. What is the potential difference in 180 ohm resistor? So the first thing you are supposed to do in this question is to work out the total resistance in the circuit. And the total resistance here is going to be, because all the resistors are in series, so we're going to say 120 plus 180 plus 150, which is going to be 450. Then once we have gotten the total resistance, which is 450, we are going to work out the total current in the circuit. And the total current in this circuit is going to translate to what? It's going to translate to 2.4 volt. It's going to translate to 1 over 75. Total current is going to be 1 over 75. The reason as to why I've left it as a fraction is so that when I'm going to multiply for us to get voltage, I get the exact value. So I'm going to say V is equals to IR, and this is going to be I is 1 over 75 times 180, because we are asked to state the PD across what? Across this 180 ohm resistor. So meaning the current that is going to flow is going to be the same for every component, and then that will mean that the current that is passing through this resistor here is 1 over 75. So if you take the current times the resistance, you are going to get 2.4, and then you will smile out of the exam room after scooping that whooping 1 mark for just doing this. Okay, so moving further to the question number 38. What is not necessary? Of course, this is this kind of circuit is a potentiometer, and the potentiometer is used to determine the EMF of the unknown EMF of a cell which is in the circuit. So basically, what is not necessary required to determine EMF is the internal resistance of the cell. It should not be known. It should not be known for you to be able to work out this. Yeah, so but the EMF of X should be a bit lower than that of E for better results. We need also to ensure that QS must be the length of QS must be determined, because we are going to be comparing the length here, and also the resistance of Q must be proportional throughout the length. Yeah, so basically that's what we are going to do in that particular part. Question number 31, and this is for May-June 2022, variant 1. We're told a straight conductor has a diameter of 0.42 and has a number of density free electrons of 8.5 times 10 raised to the power 8. In a given time interval, the charge is 0.15 coulombs moves through the wire. Then what is the average displacement? We are asked not velocity, we are asked displacement. I know it's going to be quite interesting, because some of us we've not encountered this kind of question before. So the first thing that the first move you will make is by identifying that current is equals to A NVQ. That will be the first thing that you are supposed to remember in this question. And then we are going to use the concept area, because this is cylindrical as a diameter. Area is pi d squared over 4, because the diameter is radius is d over 2, isn't it? So if you take d over 2 squared, is going to be d squared over 4. Then we can be able to work out the area of that wire, yeah, the cross-section area of the wire that we are having in consideration. So we are working out the cross-section area of this wire. Then once we have done that, we need to remember that because we said we're going to use current is equals to A NVQ, then we are going to appreciate the fact that charge is equals to what? IT. So here, then from charge is equal IT, we can be able to say current is equals to charge over time. So I got this formula. Then having that, do you remember velocity is displacement over time? Also, do you remember that? Okay, so from there we can be able to make T the subject of the formula, and our T is going to be L over V. So charge, from this formula that we have here, we can now therefore say charge is equals to L over V is equals to area times charge density times velocity or speed of the charge carriers Q. So which means that from this point we can be able to say, if you want to get rid of this V from here, you multiply both numerator and denominator, so we shall have QV over L. QV over L is equals to ANVQ, and V will cancel out. We are going to remain with L is equals to charge over cross-sectional area over NQ. Then we can now be able to apply the formula by substituting charge was what? 0.15. Cross-section area we got 1.39 times 10 raised to power negative 7, and then times the charge density N was given in this question, it's here, and then the charge of one electron is 1.6 times 10 raised to power negative 19. So which means that if we are going to work it out, we are going to get 7.9 times 10 raised to power negative 5, and our answer translates to C. Our answer is C, shown there if you round off that. Now, what is the definition of potential difference? This is not the first time we're meeting this question, and also if you meet it in the exam, it's not the first time you'll be seeing it in the streets. So we're having it as charge transferred to the component per unit charge. Yeah. The graph shows IV characteristics of a semiconductor diode, and the diode is a device that allows current to flow only in one direction. So, and that is how the graph will look like. Which statement deduced which statement can be deduced from the graph? Above certain positive value, the different diode obeys Ohm's law. No, Ohm's law is obeyed when we have a continuous straight line, and a current is directly proportional to the potential difference. If we are saying that, it means that line was like that, directly proportional, and that is not the case. Then we also need to read the third one. Diode has zero resistance when the current is in one direction. That's not the case, because you can see here there is current in this direction. Also in the opposite current of opposite direction, current can be read at given point. So we can say the resistance of the diode depends on the potential difference across it, and that is going to be our answer for that is going to be D. This particular question now, we are told that in question number 34 that a wire has a resistance of 30 ohms. A second wire is made from the same material and has the same mass and 3 times as long as the first wire. What is the resistance of the second wire? So that's what we are told. Now, in order to work out this, we need to remember that density D is equals to mass over volume. And from this formula, density is equals to mass over volume, we are going to say that density is equals to mass over AL, because cross-section area times length is going to give us volume. Then we shall, from here we are going to make the subject of the formula, right? We are going to make what? We are going to make A the subject of the formula, so we shall have our equation reducing to A is equals to MdL. Once we have gotten this, we are going to substitute that into the formula. We know resistance from resistivity is going to be R is equals to resistivity times length over cross-section area. But now we had said A is equals to mass over density times length. So we can be able to get R in terms of that. So we shall say R is equals to resistivity times length over MdL. Yes, at that given point. So, which means that it's going to be what? So I've explained up to this point. So R is equals to resistivity times L over M over dl. So if we multiply dl both sides here, this equation is going to be P resistivity times density times length squared over M. So that's the formula for resistance. Resistance is equals to resistivity times the density. D here is density, L is the length of that, and then we are going to therefore say that over M. But we are told for the second wire, it has the same as that. The second wire is made from the same material, so density will be the same, mass will be the same, and the mass you are told here is the same. So we are going to say resistance of the second wire is going to be, resistivity is going to be the same, times density is just the same, but the wire is 3 times as long as the other wire, so it's going to be 3L. If you raise power 2, that becomes 9. This becomes 9. So our equation ends up being R for the second resistance for the second wire will be 9 resistivity times the density times L squared over M. But all this that we are having here, all that we are having at this given point here is representing the resistance of the first wire R, and resistance of the first wire was 30. So which means that for us to get the second resistance, it will be 9 times the resistance of the first wire, and that's going to become 270, and this is why our answer should be 270 ohms. Basically, that's what you are supposed to do. That's what you are to do in that particular question. All right, so moving to question number 35. Question number 35 says, a cell has internal resistance R, and electromotive force of E. The cell is connected in series with an ammeter and a variable resistor as shown here, where R is 10 ohms. R is 10 ohms. And the ammeter reading is 0.3 amperes. When R is 10 ohms, the ammeter reads 0.3. When R is 5 ohms, the ammeter reading becomes this. So how are we supposed to find the value of E? So in order to work out the value of E, we are going to form 2 simultaneous equations for E. So something we need to remember here is that E is the electromotive force, and electromotive force E is equal to the terminal voltage plus the potential drop due to the internal resistance. So we can be able to say terminal voltage is the current that is flowing through the circuit times the external resistance plus the current that is flowing through the circuit times the internal resistance. So if you use that relation, and when the external resistance is 10 ohms, we have a current of 0.3 amperes. So we shall say electromotive force is equals to 0.3 times 10 plus 0.3 times R. R is the internal resistance of this particular resistor of this particular cell. Then also we do the same for the second information. 5 ohms for gives a current of 0.4, and if we equate the two, because both of them are representing the EMF for the same cell, so we are going to equate this equation and that. And so if you work it out, you are going to solve and get the value of 6 volts. So the answer for that is going to be 6 volts. What's the definition of potential difference? I'm not going to repeat that because we have mentioned for quite some time. Is the energy transferred per unit charge. The resistance of a filament lamp increases as the current in the circuit increases, and this is because there is increase in temperature, and when temperature increases, that's going to result to an increase in resistance. Yeah. Moving to question number 3, we are told that a battery of electromotive force EMF 12 volts and negligible internal resistance is connected to a fixed resistor. Of 40 ohms. The thermistor RT is as shown there. Initially, the temperature of the thermistor is 15 degrees Celsius, and the current in the circuit is 0.1 ampere. The temperature of the thermistor changes, which causes the current to increase. What will cause current to increase is a decrease in resistance. So if resistance decreases, current will increase. And what will cause the resistance of a thermistor to decrease is the increase in temperature. So how does the temperature of the thermistor change? Because the current increased, it means resistance decreased. And the resistance will only decrease if the temperature of the thermistor is increased. So we're going to say that is the answer in that. But how do you get this 60? Yeah, not 100. So we need to appreciate, we are told that the current that flows is 0.12. So which means EMF is equals to terminal voltage plus IR, the voltage drop due to the internal resistance. So this is going to be 40, yeah. So am I talking about terminal, where am I mixing these things? I'm mixing things up here. So if there's a current, of 0.12 amperes flowing through the circuit, it will mean the potential drop for this resistor will be 40 times 0.12. We get the answer. And also, if there is that current that passes through is the same current that will pass through this one, so the PD there will be 0.12 times RT for the thermistor. So if you add this voltage and this voltage, it will give you the voltage of the battery. And if you do that, you are going to get 4.8 is equal to 0.12 RT. Then if you work it out, you are going to get 60 ohms. 60 ohms. A cell of electromotive force 3 volts and internal resistance of 0.5 is connected to a variable resistor. The voltmeter and ammeter is as shown there. So we are told the voltmeter reading. The reading on the ammeter I is recorded. Yeah. So if we are having this is the EMF. So the highest voltage this battery can have is going to be 3.0, and we are going to say now 3 divided by 0.5 is going to give us 6. This is the current. So we are going to have our answer for that. Three resistors R1, R2, and R3 are connected in parallel to a cell. Three resistors R1, R2, and R3 are connected parallel to a cell. The current in the resistors are I1, I2, I3. The potential difference across is V1, V2, V3. The current in the cell is I0. The potential difference across is V0. So which equation obtained? Which equation can be obtained by applying Kirchhoff? Which equation can be obtained by applying Kirchhoff's second law to the circuit? That is going to be, remember, Kirchhoff's second law states sum of EMF around the circuit, around the loop, is equal to the sum of PDs around the loop. So we are going to say V0 is going to be equals to V1 equals to V2 equals to V3, because if you consider this as a loop, we are going to say V0, which is the EMF, is equals to the PD for this particular part. Also, if you consider this loop only, we are going to have V0 is equals to V2, and also if we are going to consider this loop here, we are going to have V3 is equals to V0. So, and then you are going to have the expression reducing to what? Reducing to C. Three resistors, each of resistance are connected in a network shown there. The total resistance between X and Y is going to be, so first we are going to combine this resistor and this one, so that's going to give us 2R. Then we are going to consider now 2R and this are going to be what? Parallel. So we shall say 1/2 plus 1/1 raised to power -1, and the total resistance in that case is going to reduce to 2/3. Then we are told that the resistance between X and Y is 0.8.0. So which means we can now say the resistance we have gotten here, we can say is 2/3 R is equals to 8. Then we make R the subject of the formula for us to get the value for R as 12 ohms. A potentiometer and a driver cell of electromotive force E are used to measure the EMF. So what is the essential requirement for the EMF of the new cell to be measured? In this case, we're going to say the resistance per unit length of the wire must be constant. The wire used here must have uniform cross-section area, and the resistance along the wire QR must be constant, because we are going to use ratios in order to work out this. The table shows a number of nucleons, so we shall have another tutorial for that. Current in a conductor is given by I NVQ. What does N represent? N represents the number of charge carriers per unit volume. Number of charge carriers per unit volume. Of course, I is current, A is the cross-section area of the conductor, V is the velocity of the charge carriers, and Q is the charge of each charge carrier. So that is, for instance, if we are talking of electrons, that's going to be 1.6 times 10 raised to power negative 19. The total power dissipated in the resistors is 24 watts. So what are we going to do in order to get the answer to that? So first we need to work out the total resistance of the circuit. So these two are in series, so we can combine them. If we are told they are identical, then we are going to say R plus R, it will be R to R. So we are going to say 1 over 1 because this is like 1 R, so we are going to say 1 over 1 plus 1 over 2, because if you add these two you're going to get 2. I'm going to include the R later, so I'll say 1 over 1 plus 1 over 2 because these resistors are in parallel. Then raised to power negative 1 to get the answer direct, and our final answer here becomes 2 over 3R. But we know power is V squared over R. Now in this case we have our R here, so we shall say V is 6, so that is 6 squared will be 36 over the resistance that we have gotten, and if you work it out you are going to get your answer equivalent to what? Equivalent to 2.3 ohms as the resistance of that. Which graph could show how resistance of a filament lamp varies with applied potential difference across the PD? So if across the normal operating, so that is going to be as V is decreased, normal operating rate, so resistance will be increasing, and then we are going to take our answer as that. A piece of conducting party is in the shape of a cylinder of length 60 millimeters, so we need to change that to meters, and diameter of 20 millimeters. The resistance between the ends of the cylinder is 20 ohms. What is the resistivity? We know that resistance is equals to resistivity times length over area, so we can make resistivity the subject of the formula to be resistance times cross-section area over L. So what you are to be careful with is the units that are provided so that you can be able to work it out. Convert the millimeters to meters and then work out the area, and if you substitute you're gonna get your answer as 0.1 ohm meter as the resistivity of this. Which statement about electromotive force of a cell is always correct? EMF is the energy converted to other forms in the cell from electrical to other forms. No, this is PD that will be defined like that. EMF of the energy provided by the cell per unit charge passing through it. That's correct. EMF is the potential difference across internal reserve. No. EMF of the potential is the potential difference across a terminal of cell. No, the answer is B. Just basically the definition of EMF. Kirchhoff's first law and second law are consequences of conservation of two quantities, and the two quantities, Kirchhoff's first law is conservation of charge, and Kirchhoff's second law is conservation of energy. So the correct answer is A in that case. Moving to question number 36. Moving to question number 36. Number 36 says the circuit contains a cell of electromotive force E and internal resistance R. Connected to a resistor capital R. The current in the circuit is I. Which equation is correct? We know EMF is equals to terminal voltage plus PD rose due to internal resistance. So if we rearrange that formula, basically it will be this formula that we have here. And terminal voltage is basically I capital R. So that's why this equation can be rearranged that way. A potential divider consists of two resistors of resistance R1 and R2 connected in series across a source of potential difference, and the PD across R1 is V out. So the formula you can use to work out V out is V out is equals to R1, where R1 is the resistance. Here is the resistance where the voltage is tapped out from. So it will be R1 over R1 plus R2 times V in. So which changes to R1 and R2 will increase the V out. So you see, if you double R1 and half R2, then it means you are going to increase the V out, because if you are going to double R1, this numerator is becoming larger, right? So we are going to have doubling R1 and halving R2 will give us the correct value, because if you are increasing this, the numerator is increased. Yes, this resistance is increased, and this one is reduced. You are going to have a larger value. That's mathematical reasoning there. A fixed resistor of resistance 12 ohms connect to a battery, and there is a current of 0.2 amperes in the resistor, and the current is now doubled. The current is doubled. So first we need to remember that power is equal to I squared R, so that we can be able to apply this formula. We are told the current is doubled, so this value that we were given here was to enable us to know that this current here is going to be 0.4 amperes. That's why basically you are given this value that we have here. So once you have that, we can comfortably say, so we can be able to comfortably say that this is going to be I squared, which is 0.4 squared times the resistance of the resistor 12, and that is going to be 1.92, which is 1.9 watts. There is a current in a resistor for unknown time. Which two quantities can be used to calculate energy dissipated by the resistor? Right? Now, we don't know time, so we need to first remember the formulas that can be used to work out energy dissipated or energy lost. The first formula is energy is equals to current times voltage times time. So we have time here. Energy is equals to power times time. So we have time there. Right? Another formula for energy is voltage times charge, potential difference times charge. So these formulas cannot help us because already we don't know time. Then the best way is voltage to potential difference times the charge. So that's going to the total charge passing through the resistor, and the total potential difference across the resistor is the best way we can be able to work out this question. Another interesting question that we were having here is that we are told two cells, each with electromotive force E1 and E2 and internal resistance R1, R2, are connected to a resistor R. So something that we need to understand is the total resistance. The total resistance in this circuit will be R plus R1 plus R2. So that is the total resistance in this circuit. So which means the total current that is going to flow through the circuit, we shall be able to add the EMF of this, and the EMF of this will give us the total EMF in the circuit. And we have also the total resistance in the circuit. So which means the total current flowing is I1 plus I2 over the resistance that we got there. Then once we have done that, we are told there is another information that is given here, that the terminal potential difference across cell 1 is 0. the terminal potential difference across cell 1 is 0. So what does that mean? If we take the EMF of cell 1 minus that internal resistance, the potential drop due to the internal resistance, the answer is going to be what? 0, because we know E is equals to V plus IR. So IR is the PD, due the potential drop due to the internal resistance of the cell, and this one V is the terminal PD. V is the terminal PD. So if we take current times internal resistance, so in this case our current is this value that we have here, the current of the entire circuit, but internal resistance for this one is R1. So if you take this value, which is the current, times R1, is going to give you the voltage drop due to the internal resistance. So that's why you can see I said E1 minus the current in the circuit times R1 should be equal to 0, because if you are supposed to say E minus IR should be equals to the terminal PD, but our terminal PD, we are told, is what? The terminal PD is 0, we are told here. So once you have done that, we have formed an equation. We can be able to take this equation on the other side, so we shall have a cleaner equation there. If we multiply all through by the denominator that we have at this point, yeah, we are going to have E1 is R plus R1 plus R2, and opening the bracket also we shall have E1 V R1 E2 R1. So we can see this part and this part will cancel out, and if you rearrange this, you are going to have our R, because we are finding resistance R. We are going to therefore say our R is equals to E2 R1 minus E1 R2. So basically that's what you're going to do in order to get that. Okay, so moving to next question, we are almost done. A battery has the electromotive force E and internal resistance R. The battery delivers a current I to the variable resistor, and the potential difference PD across its terminal is V. The variable resistor is adjusted that I increases. Why does V decrease? So if I increases, if current increases, meaning that if the variable resistor here, resistance of the variable resistor is decreased, there will be more current flowing through the circuit. Then why is V going to decrease? V is the terminal potential difference, and is going to decrease because large amount of current is going to be drawn from the cell. Because of low resistance, more current will be drawn from the cell, and when there is more current drawn from the cell, we are going to have a large potential drop due to the internal resistance of this cell that we have here. So because if you have a large amount of current, then we're going to have a large potential drop due to the internal resistance of this cell, and that's why we're going to say the PD across R increases. Three identical resistors are connected between terminals P and Q. Which order of increasing combined resistance between P is we start with the lowest first. Of course, I started by finding the total resistance for X. So we shall say these two will be in series. So if we are having one having resistance R, then we are going to say R plus R will be 2R. So we shall have 2R over 1 over R. Working out everything, we are going to get this value. These are, all of them are in parallel. We shall say 1 over R plus 1 over R plus 1 over R. And everything is going to translate to 1 over 3. This is 2 over 3. And this one, we have these two in series, in parallel. You shall first work out this by saying 1 over R plus 1 over R. Working it out, you shall get 1 over 2R. Yeah, the 2 will translate to 1 over 2R. Then since we have another resistor here, which is in series with this one, so we shall say 1 over 2R plus R. And this is the total resistance we shall be having in this particular point. So arranging them, you are going to have your answer as C. We have question number 37. The diagram shows a variable resistor R and two fixed resistors connected in series in a circuit to act as a potential divider. So the cell of electromotive force 6 volts has negligible internal resistance. And we have a cell of EMF 2 volts and a galvanometer are connected into the potential divider. And the resistance of R is varied until the galvanometer reads 0. So the galvanometer will read 0 because here we know the PD is 2 volts. And if the galvanometer reads 0, then the potential drop between these 2 points is also 2 volts. So if we are having 2 volts here, because this is 2 volts, for it to read 0 I've mentioned, we shall have the potential drop between this point and this point should be 0, as should be 2 volts as well. But if this is 2 volts here, the entire wire and along this part should have 6 volts. 6 volts. Already we have 2 volts here, so which means the PD across the 10 ohm resistor is going to be 4 volts. So we can be able to calculate the current that is flowing through the 10 ohm resistor by using the voltage and this resistance, and this is going to be 0.4 amperes. So is what? 0.4. So the current that is passing here is 0.4. The current that is passing through this resistor is 0.4. So if there is a current of 0.4, then we can be able to work out voltage as IR. So the voltage across these 2 ohm resistor will be 0.4 times 2, which is going to give us this value, and also 0.4 times R. That's why we are having this. Then if you take the 0.8 on the other side, we shall have 0.4 is equals to 1.2. Divide by both sides, we shall get our resistance R to be 3 ohms, like that. So basically this is all that I wanted us to talk about in this particular tutorial, and I believe it was a good clinic for those guys who are going to do electricity AS paper. I wish you the best. Good luck in the next paper that you're going to have.